Let's take a closer look at how atoms give, take, share, whatever, their electrons in order to form bonds and make compounds. A compound has at least two different atoms bonded together into a unit, into a compound. Remember, we said that ionic bonds are when one atom wants to gain an electron and one wants to lose one, or more than one. And therefore, since one wants to gain and one wants to lose, it's the perfect match and the opposite charges attract. So when one atom wants to get a positive charge and one wants to get a negative charge, that's when they make an ionic bond in an ionic compound. So the metals are to the left of the stair-step line. They have the positive charge, and they are the ones that want to, let's see, positive means lose, it's backwards. They want to lose electrons. Nonmetals are to the right of the stair-step line, and hydrogen. And the reason hydrogen goes over here is because it wants to lose electrons like the metals. So that's why it gets put with the metals, even though it's actually a nonmetal. So the nonmetals are to the right. They want to negative gain electrons. So when you have a metal and a nonmetal, then you will have an ionic bond. In an ionic bond, electrons are given and taken or transferred from one atom to another. And they make positive and negative ions. Remember, cations are positive and anions are negative. Then the oppositely charged ions attract and make an ionic bond. So the attraction between the positive ion and the negative ion is the bond. Ionic compounds are made of a metal and a nonmetal. Because these like to lose, these like to gain, it's the perfect combination. So here's how the metals and the nonmetals arrange themselves in an ionic compound. You'll have a positive ion, then a negative, then a positive, then a negative. In the next row, you'll have a negative, then a positive, negative, positive. See how that works? So notice that this positive ion is surrounded by negative ions, and this negative ion is surrounded by positive ones. That is much more stable because the opposites attract. That is called a crystal structure or a crystal lattice. The atoms arrange in a repeating pattern which causes the compound to form crystals. Ionic compounds are always crystalline solids at room temperature. They have very high melting point. For example, table salt is a crystalline solid. You've seen salt crystals. And have you ever seen melted salt? Probably not. You might have seen dissolved salt, dissolved in water, but that's very different from getting hot enough to melt. And so you have to get salt so hot to melt it, several thousand degrees Celsius, that you probably have not actually seen it. Ionic compounds are brittle. They shatter when they're struck with a hammer. The reason is if you hit this positive ion and push it down, it will be beside another positive ion, and then this negative ion will be beside another negative, and yes, opposites attract, like repel. So the two like charges, two positives or two negatives, will repel each other, and the crystal will break. So when you take a hammer and strike salt crystals, they'll break into smaller pieces. So ionic compounds conduct electricity under two circumstances. It's pretty neat. They actually conduct electricity when they're melted or when they dissolve. The reason they do this is because here's your positive and your negative ion, and when you melt it or dissolve it, the ions separate or dissociate. They're dissing each other because they don't want to associate with each other. Speak to the hand. So when they dissociate or break into ions, the positive and negative ions can move around and they can carry the charge, which helps it conduct electricity. Next, let's look at covalent bonds. Covalent bonds are found in molecular compounds. I know that's crazy, right? So covalent bonds are when both atoms want to gain electrons, and they end up sharing because they both want to gain. So the electrons are shared in a covalent bond, and they form a molecular compound. Ionic bonds are found in ionic compounds. Metallic bonds are found in metals. Why couldn't it be easy like those? So here's an example. Notice I've color-coded. The hydrogen had 1 electron and wanted 2. So did this one. The oxygen had 6 electrons and wanted 8. By sharing, the hydrogen now has 2 electrons, and so does this one. And the oxygen now has 8 electrons. Molecular compounds can be solids, liquids, or gases at room temperature. Water is a liquid. They usually have low melting points. For example, water has already melted at below room temperature. So if it's a liquid or a gas, liquids have already melted and gases have already boiled. Technically, you're breathing boiling oxygen right now. Kind of crazy, huh? But it's not the boiling point of water, it's the boiling point of oxygen, which is like negative, extremely cold Fahrenheit. So the oxygen has already boiled. You're breathing it, but its boiling point was so low that it's room temperature oxygen. It's not going to hurt you. Molecules, molecular compounds, do not conduct electricity because they're not made of ions and they can't break up into ions, and therefore they can't carry that charge around. Finally, metals make metallic bonds. When two metals are mixed, they don't actually make a compound. They make an alloy, which is a mixture of two metals. They don't actually react, they just stir together. How do you mix two metals? Well, you melt them first and then stir them together and then let them harden again. That's how they make brass, bronze, steel. Those are all mixtures or alloys of metals. Metals, remember, want to, positive, lose electrons. So if everybody wants to lose their electrons and nobody wants to gain them, it's kind of like they're playing hot potato with their electrons. Here, take my electrons. No, you take mine. No, you take mine. And they're throwing the electrons back and forth. And that's why metals conduct electricity, is because the electrons are so free to move around because everybody's trying to give them away. But what happens is when you give away an electron, you lose a negative, you get a positive charge. And then opposites attract. The positive charges and the negative electrons are attracted. And that's what causes the metallic bond. So it's like, wait a minute, I thought they wanted to give them away, and now you're saying they're attracting. Well, they're like a 2-year-old. I don't want my toy. I want my toy, give it back. That's kind of how they are with the electrons. I don't want these electrons. Wait, now I'm positive and they're negative, give them back. So the electrons are free to move about, and that's why metals conduct electricity and conduct heat. So two metals both want to give away electrons, therefore they will not react, they just make a mixture called an alloy. Here is a picture of what a metal looks like on the atomic scale. The positive cations have lost their electrons, and the electrons are kind of free to move about everywhere. You need to draw these three for your notes, so just sketch them on a sheet of paper, take a photo, and upload that to Canvas. Metals are usually solids at room temperatures. Most of these metals are solids. There is only one exception. Mercury is a liquid. If you've ever seen a shiny, silvery thermometer, that's a mercury thermometer. And that silver metal inside is actually liquid mercury. In fact, I used to look at the tip of a mercury thermometer and think that that was a metal tip. It was actually a glass tip filled with liquid metal mercury. And the mercury is very good at conducting the heat, and as the mercury heats, it expands, and that's what makes the mercury rise up the thermometer as it gets hotter. Now, mercury is poisonous. You've heard of Mad as a Hatter, or the Mad Hatter? Why are hatters mad? Why are they crazy? Well, it's because mercury is poisonous. Hat makers, back before they had plastic and other stuff, and they were making let's say a top hat out of felt, they wanted to put a shine on the top hat. And so what they did, they would take mercury and rub it on the hat with their hands. And the mercury absorbed through their skin and poisoned them. Also, the mercury vapors would evaporate, they would breathe it, and that's another way they got poisoned by the mercury. And mercury poisoning causes you to go insane. So, hat makers went crazy, so you were mad as a hatter. So, mercury is the only liquid metal at room temperature. Gallium is another metal that melts at very low temperatures, just slightly above room temperature. And they used to put gallium in sprinkler systems as the plug in the sprinkler. And if the room got too hot, the gallium would melt and drip out of the sprinkler, and then the sprinklers would start spraying water. The problem was you couldn't turn it back off. You'd have to turn off the water out at the road to get the sprinklers to quit spraying water. Then again, if you've got a fire, that might be a good thing that it doesn't quit. So these are all solids. Metals tend to have medium-low melting points. When a metal is struck with a hammer, it does not shatter, it bends. That's because, remember with this one, when you hit it with a hammer, the positive got beside the positive and they repelled and it broke? Well, the positive is beside the positive, but the electrons can zip in between and prevent them from repelling each other. So even when you push this positive down beside the other positive, the electrons just slip around in between and prevent them from repelling each other. Therefore, metals don't break, they bend. Well, you can break a metal, but they're more likely to bend first. And this is also why they conduct electricity. The electrons are free to move about. This is sometimes called a sea of electrons, because the electrons are constantly moving, like the ocean is constantly moving.